So we've walked through a distributed threshold ECDSA algorithm to the point where we get to Byzantine fault tolerance. But what is this Byzantine fault tolerance? I've got some papers here that describe it, and also the honey badger. It's worth reading, especially Lamport's paper. If you've never read an entertaining computer science paper, that is the best one in existence. And it's very readable, whereas the practical Byzantine fault tolerance goes right back to all the dull stuff and is very hard to read, but very useful, as in practical, as opposed to the original paper that isn't particularly practical, but it's the one from which the term Byzantine fault tolerance comes. And Lamport's paper is very good for understanding what the problem is. So what is Byzantine fault tolerance? Byzantine fault tolerance is building a distributed network where you assume absolutely the worst about the nodes in the communication, and you still want to end up with reliable results at the end. Reliable results being consensus. So, at a certain level, nodes in your network can fail. They could be malicious. You can have communications that can fail, and the communications itself could be malicious because you could have something like a man in the middle that is changing messages while they're being transmitted. So either way, you have failures of nodes and failures of communication. And seriously, what can go wrong? I mean, let's talk about how, if you've got a network, things can go badly. Computers do crash, and that's reality. Or they do worse than crash. Here's the one that I always love. The computer crashes, then it reboots, then it crashes, then it reboots. And in between each crash and each reboot, it communicates just long enough for you to believe that it's working when it isn't. So that's just a joyous thing. Data gets corrupted. Yes, there is such a thing as data rot. In fact, even on good disks, eventually stuff goes south. And you get database errors, and you get read errors, and you get partial read errors, or you get stuff coming through that is an electrical spike, and at that moment it appears to have a read error, but then the read error goes away later. Always good. Services are just gone. I have, in the past couple years, had a client that they were relying on a Google service that they didn't realize had been deprecated, and yes, the day came when Google shut down that service, and they were going, yes, but... well, it's gone. Deal with it. One of the most common in the land of databases is the query of death. This is where you have, 50,000 rows in the table you care about, but there's this other thing in the database where you've got some historical piece of data, and somebody in the business department goes, yes, but we really should, without an index, join 30 billion rows back to itself 17 times in a row, and it'll only run slowly. It just takes a little while, 8 days to run. It's always a good thing. There's malicious stuff, like denial of service attacks. These are more and more common. In fact, my neighbor across the street, he has a nice camera, a security camera on his yard. And he made the comment that, yes, well, I log into it over the web. And I said, did you change the password? And he says, I don't think I can. It took me about 15 minutes to find the password. And now I can see his yard as well. And I can load software onto his camera, and I can use it as a bot for denial of service attack. In fact, I've determined that the password on that system is baked into the ROM and is fairly obvious, and you can't change it. So it's just out there. You can Google search that model of camera, and you can just find the password. And anywhere you find one of these cameras, and there are a lot of them, you can just use it. Now, the opposite of denial of service attack, which is malicious, is the flash crowd. Yes, you did something, and on your nice server that you're running some useful stuff, you also have your web page, and your web page is suddenly swamped because, yes, you went viral. And suddenly you're getting 50,000 requests a second, all from different legitimate sources, but yes, it's 50,000 a second. And was your server ready for 50,000 a second? And that's at the low end. I've seen flash crowds go to millions per second because, yes, this got posted someplace and it was popular, and suddenly everybody went, oh, let me go take a look. So popularity is one. If you have a set of servers, just one of them crashes, something goes wrong with it, the power supply fails, the CPU burns out, the fan, that's the most likely actually, dies on the CPU, and guess what? It cooks itself to death. Or even worse, it doesn't cook itself to death, it just cooks itself to really, really slow so that it doesn't cook itself to death. That's more common these days. And the fan isn't working, but you can still log in, but now it can do like 4 requests a second because it's running slowly. How about the data is lost? It's just plain gone. There's no recovering it, never getting it back. Or you had a security breach and intentionally the data is gone because somebody deleted it. Or they encrypted it and now they're demanding ransom for you to decrypt it. And the two biggies in all network things. The backhoe. I was working at a company many years ago. I was up on the 6th floor. And outside my window, they were building a building. And I watched one day as the person managed to backhoe the power supply. And there were all these sparks, and you could hear this boom and sparks and everything. And suddenly the person leapt off the backhoe onto the ground, and you can see sparks flying across the backhoe. And the power was off in our building. That's actually one of the more common things to have happen, is either the backhoe through the internet connection or the backhoe through the power. In this particular case, the emergency power supply kicked on in our building, and our stuff was just fine for a week until they had a power fluctuation and the power went off and nobody remembered to refill the diesel generator in the basement, and the power went off really, really hard, as in even the emergency lighting in the building quit. So, it can be a delayed backhoe event too. And the most common, of all network and power failures, the number one, is, according to folks like AT&T, 1,847 more times likely than everything else put together, are squirrels. Yes, this is more likely than earthquakes and terrorists and everything else by orders of magnitude, is the vicious squirrel. I was working in a building one day, the power goes off, and we look outside and we can see that the streetlights are still on, and we go outside and there is a horrible smell, and yes, laying on the ground underneath our power transformer is the remnants of a very cooked squirrel. And he shorted the power transformer on our building and it was out. And I feel sorry for the squirrel, but yes, killed, dead. And it turns out that is the number one thing, is the horrible attack of these vicious, malicious squirrels. So just remember, squirrels are number one. And then there's the unlikely things, although, we do see them, like fire. I have been in a building that didn't have a fire, but they set off the automatic sprinkler system because they thought they had a fire, and so much for that data center. Floods, that was kind of a flood after they set off the automatic sprinkler system. There was 3 inches of water on the floor. Earthquakes. I was giving a presentation once in front of a group of venture capital people when suddenly I noticed we were having an earthquake. Yes, they are real. I have also been in an earthquake in a basement between stacks of books. Man, you've never seen anybody get outside so fast as I did. Now, the one I've never seen is volcanoes. It's just, I don't want to. I don't want to be too close to a volcano. That's, on volcano day, I want to be someplace else, not Pompeii. So, of course, in the land of fires, there's also your system has caused the fire. I've been at people that have had that one. Or how about just the data center was raided or the office was raided by the FBI? Yeah, there's this Steve Jackson Games many years ago, and you can look us up in the communications of the ACM. They had a nice article on it that got raided by the FBI because they thought they were doing hacking when in fact they were building a desktop card game, of which I actually have a copy these days, called Hackers, that is fun to play. And the FBI raided their computers for this horrible activity because they were hackers, because the FBI was too stupid to be able to tell the difference between somebody that's building a game and somebody that's actually doing it. And yes, 4.5 years later, they still hadn't gotten back their computers. So, yeah. Or you have actually had a node in your network hacked. You know, you can't exclude the possibility that you actually got hacked. It's real. I have been hacked maliciously, and yes, it is very real. Or you have a system administrator in your system that makes a typo. My favorite one was the day that the person was supposed to do rm-r./dev, and instead they typed rm-rf/dev on a Unix system. Dev is the directory that has, they were at as root, and it is the directory that has all of the connections between the OS and all the applications. And that's kind of fatal when it starts deleting those. Another one that I've seen, and this was quite some years ago, is there is in /dev a device called null. Null, when you read it, is supposed to return an immediate EOF, and when you write to it, it just gets rid of everything. And it turns out that lots and lots of applications rely on /dev null returning an EOF so that they can build an empty file. Like every temporary file in the entire system depends on this. So you have a database, and suddenly it's expecting to get an empty file when it starts doing things. Instead, it gets a file with data in it because somebody removed dev and they replaced it with an actual file. So that every time something writes it to it expecting to get rid of this data, instead the data reappears someplace else for mysterious reasons because the /dev is gone, or /dev null is gone.